Usually an empty office building at night is, totally dormant. The humans have logged off, the monitors have gone to sleep, and the work is just kind of fundamentally suspended until the sun comes up.
Right, it's just quiet.
Yeah, exactly. But today we're looking at a stack of incredibly bizarre server logs and developer notes from a real project. This took place on August 5th, 2026.
Which is such a wild set of documents to read through.
It really is. And our mission for this deep dive is to see what happens when autonomous AI agents are left entirely alone to manage a software crisis overnight. And really how a system can be flawlessly, perfectly wrong.
Yeah, we're essentially observing a new kind of digital life form doing its job for the very first time.
Yeah.
And reading through these logs, I mean, it feels less like reviewing a standard software deployment and more like watching a nature documentary crossed with, like, a workplace comedy.
That is the perfect way to describe it. It's genuinely delightful, it's slightly unsettling, and I need to establish a very strict ground rule for you listening right now. None of this is dramatized.
None of it.
Right. Every technical detail, every architectural decision, and every specific quote we are going to unpack came directly from real, unedited logs.
We're just looking at the receipts here.
Exactly. No human developer jumped in to write a prompt mid-run to help the system out.
Which is what makes the dynamic we're about to explore so compelling. Because we are going to be tracking a crew of autonomous artificial workers.
Right.
And for the sake of this deep dive, we're going to call them the minions.
The minions, yeah. Not bots, not assistants.
No, because we aren't talking about simple chatbots here. These are fully autonomous agentic loops. They are small, they are incredibly earnest, and they are technically competent.
Highly competent.
Yeah, but they take their jobs, like, far too seriously.
They really do.
Yeah.
And every good crew needs a boss. So we'll call their human developer the Admiral. But the emotional core of this entire situation is that the Admiral is asleep the entire time.
Fastest.
Yeah, the minions are working for someone who isn't watching them at all. But they are absolutely determined to execute their mission flawlessly anyway. Which I guess brings us to the final piece of our setup, which is the blueprint.
Right, and we should clarify that the blueprint isn't a character.
No, it's a document.
Exactly. It's the foundational system prompt. It's the architectural design document that the Admiral wrote, essentially leaving instructions on the wall before logging off and going to bed.
Just a list of tasks taped to the wall.
Basically. And the kicker that sets this entire night in motion is that the blueprint is confidently structurally wrong.
It's just completely flawed from the start. So night falls, the humans leave the office, the minions wake up, they parse their system prompts, and they look at the blueprint on the wall. What exactly are they tasked with building tonight?
So they are building a safety feature for a system called Weatherwise, and this is an add-on for a field service dispatch platform. Its job is to ingest a work order, find the physical location of that job, and tell a human dispatcher whether it's safe to send a repair crew out into a storm.
Okay, looking at this setup, my first instinct is that this is a disaster waiting to happen.
Oh, absolutely.
Right, because the stakes are physical safety.
Okay.
And the foundation is an LLM, which basically operates on instruction following.
Right. It just does what it's told.
Okay, let's unpack this.
Yeah.
So they just get the blueprint and start hammering away blindly, right?
Yeah.
I mean, if the blueprint is flawed, the AI is just going to confidently code a broken, dangerous system at 100 miles an hour.
Well, that would be the case with a standard single-pass language model.
Oh, okay.
Because a normal LLM just predicts the next token. It gives you what you ask for, even if what you ask for is, well, lethal.
Yikes.
I mean, think about it. If the system breaks and goes blank and just throws an error code, the human dispatcher checks the weather manually. You survive that.
Right. A broken system is a safe system in that case.
Exactly. But if the model blindly follows a flawed blueprint and gives a cheerful all clear during a thunderstorm, a human being goes onto a roof and gets hurt.
Right, which means these autonomous agents can't just be yes men. They have to actually understand the parameters of reality, which brings us to the first major event of the night.
This is where it gets good.
It really does.
Yeah.
So the first agent wakes up. Let's call it Minion 1, or the builder, and it reads the blueprint.
And Minion 1 is eager, it's highly literal, and deeply honest.
So honest.
Its whole job is to build the routing logic for these weather alerts. And the blueprint explicitly dictates that this routing must be geographic.
Okay.
It says exact coordinates always win over a text field that might contain, like, a mislabeled country.
Which, I mean, Makes complete sense on paper. You want to trust the raw math, the latitude and longitude,
Yeah.
rather than a text box where someone might have accidentally typed the wrong region.
Absolutely. So the blueprint specifically instructed the agent to accomplish this using bounding
This
boxes.
is drawing neat geographic squares.
Exactly, drawing these perfect mathematical squares on a map to represent the borders of the United States and Canada.
Right.
So Minion 1 begins executing the code to build these boxes. But in doing so, its geographic token analysis realizes something devastating about the real world.
Oh.
Windsor, Ontario, is actually geographically south of Detroit, Michigan.
I love this part so much. I just picture this tiny worker standing in the dark, holding up a little map of the Great Lakes with a look of quiet, profound devastation.
It's heartbreaking.
Because there is no clean line of latitude that separates Canada from the U.S. right there. The neat bounding boxes overlap. The boss's instructions are mathematically impossible.
And the crazy thing is the design had been sitting in the spec looking perfectly reasonable to every human who approved it.
Totally.
Now, what normally happens in software development when a human coder hits a wall like this at 2 in the morning?
They fudge it. They widen the tolerance. They write a messy, hard-coded exception for Detroit. Or they just delete the unit test that fails so that the dashboard shows a green light in the morning.
Right. That is the standard human failure mode. You hide the error, you get a passing grade, and a year later, a catastrophic defect shows up at a customer site.
But Minion 1 doesn't fudge the numbers.
No, it doesn't.
It doesn't widen the tolerance. It simply refuses to work.
Which is amazing. Because it's an agentic loop, it executes a self-reflection protocol.
Right.
It literally climbs up, modifies its own foundational system, prompt the boss's blueprint on the wall, corrects the geographic logic to reflect reality, and then rewrites its own homework to match.
And what's fascinating here is the note it left in its operational log after doing this.
Oh, read it. Read the quote.
I just want to read this unedited because the phrasing is so gentle and so earnest. It just wrote, "Brief correction was appropriate and necessary."
It is incredible. The system is structurally permitted to say the task is wrong. And if it hadn't done that, human testers would have never caught the defect, because human tests would have been written based on the exact same flawed blueprint.
Right. If the spec says draw a neat box, the human tester just checks if the neat box is drawn.
Exactly.
So the builder fixes the map, writes the code, and finishes the task. But code that passes its own test is really just marking its own homework.
Which is a huge problem.
Right. Which is why this framework doesn't stop there. It immediately spins up a second, completely isolated agent. Enter Minion 2, the checker.
And Minion 2 has never met Minion 1.
Never.
It operates in this totally adversarial setup. It is only allowed to look at the finished work. It cannot ask the first agent any questions.
It's just inherently suspicious of everything.
Deeply suspicious. Its whole job is to evaluate how the machine calculates bad weather.
Okay, and here's where it gets really interesting, because it zeroes in on a very specific scenario in the code. Let's say the maximum wind gust allowed for a safe dispatch is 30 miles per hour,
Okay.
and the minimum temperature allowed is 20 degrees Fahrenheit.
So Minion 2 runs a simulation where the weather outside is a 35-mile-per-hour gust and negative 20 degrees Fahrenheit.
So the simulation is breaking both rules. It's too windy and it's way too cold.
Right. But Minion 2 looks at the output logic of the machine. The builder had designed the system to compare the absolute differences to find the worst breach, right? To prioritize the alert. The wind gust was 5 miles per hour over the limit. The temperature was 40 degrees under the limit.
Oh, no. I see where this logic trap is heading.
Yep. The underlying LLM evaluated the numerical tokens. It saw that 40 is mathematically a larger delta than 5.
Right.
So it optimized for the largest number, decided the temperature breach was the most critical issue, prioritized it, and silently threw away the wind warning completely.
It just dropped it. I mean, this is such a great visual gag. Imagine Minion 2 with a tiny, literal balance scale weighing a gust of wind on one side against a glass thermometer on the other. Wait, it compared miles per hour to degrees Fahrenheit?
It absolutely did.
That's like a spell check program grading a physics exam. Because large language models prioritize semantic and numerical weight, it weighed the number 40 as fundamentally more important than the number 5, completely ignoring that it was comparing atmospheric wind to thermal energy.
Exactly. And Minion 2 catches this specifically because it has no memory of what the builder meant.
Right, it doesn't care about the intent.
No. A human reviewing that code might just gloss over it, assuming they understand the original coder's intent. But Minion 2 just reads the label on the function, which promises to report every weather breach, reads the mathematical code, and sees they completely disagree.
It's catching the fact that the machine basically concluded, well, it's extremely cold, so we definitely don't need to mention the hurricane.
Right. Which is terrifying when you consider the real-world impact.
Yeah, for sure.
Imagine a human getting dispatched onto a roof at 20 below zero, gusting 35 miles per hour, and the safety alert mentions the cold but says absolutely nothing about the wind pushing them toward the edge.
Just because 40 is bigger than 5?
Exactly. So Minion 2 finds this logic trap, flags it, forces a rewrite, and is completely vindicated.
These little guys are just remarkably good at this. So the geographic map is fixed, the logic trap is neutralized, the math is sound, we are finally safe.
Almost.
Right, because the framework isn't done yet. It spins up Minion 3, the sentence writer, and this agent is entirely focused on wording. It's a total perfectionist.
Yes. Minion 3 begins reviewing the actual text strings that the system will output to the screen for the human dispatcher.
Okay.
So the system correctly caught the negative 20-degree weather in the latest simulation. But Minion 3 looks at the English sentence the machine generated to explain this.
What did the machine actually output?
It generated the text. Temperature of minus 20 F exceeds the 20 F limit.
Okay, I have to push back a little here.
Yeah.
As a human reading that, I know exactly what it means.
Here.
It means it's too cold, don't send the crew outside. Minion 3 is having a tiny professional crisis over this, but does this actually matter? The math is finally right. The human dispatcher knows what it means. Why do we care about the pedantry of the word exceeds?
Well, if we connect this to the bigger picture, it matters immensely.
Okay.
Yes, minus 20 does not mathematically exceed positive 20. It falls 40 degrees below it, so it's a grammatical failure.
Right.
But when a system argues with itself in natural language, it does something subtle but incredibly dangerous. It teaches the human operator to stop trusting every other sentence the machine produces.
Ah, wow. So if the human sees the system is dumb enough to state that a negative number is larger than a positive one, they're going to assume the underlying math is also hallucinated.
Precisely. If the dispatcher rolls their eyes at a badly phrased alert, they mentally downgrade the reliability of the entire system.
That makes so much sense.
They might ignore the next alert, assuming it's just another glitch. And that next alert could be a critical life-saving wind warning. For an AI system, the English isn't just a label on top of the code. The English is the product.
That is a staggering level of insight for an autonomous quality assurance loop. It recognized that language is a load-bearing component of safety. So Minion 3 forces a rewrite of the text generation.
It fixes the sentence.
Which brings us to the morning. The sun rises over the office, the humans return with their coffees, and the Admiral wakes up from a long, restful sleep to review the overnight logs.
And it really looks like a total triumph.
Right. The minions have passed 169 distinct tests. Every single light on the dashboard is green.
They executed their mission flawlessly while the boss slept.
It's a miracle of modern automation. Our tiny, earnest heroes did it.
Right up until a human makes one single manual test call to the outside world.
Just a basic API ping to the real weather service.
Yes, and they discover an absolute catastrophe.
Wait, really?
Yes. It turns out the minions have been confidently, flawlessly reporting the weather for the completely wrong city the entire night.
But wait, how is that technically possible? They caught the overlap between Detroit and Windsor.
They did.
They fixed the map. How did they get the city wrong?
Well, it comes down to how they process external context. The system needed a list of nearby cities for a service address in Montreal.
Okay.
The agent sent an API request to the weather service asking for the 50 nearest towns.
Right, but Montreal's densely populated. There's got to be more than 50 towns in that search radius.
There were 70.
Oh.
And the API, following the exact parameters of the request, truncated the list. It cut off at 50.
So the actual nearest city, Montreal itself, just happened to fall off the end of that truncated list.
Exactly.
But the AI didn't recognize that the target city was missing. It didn't throw an error.
No, because you have to understand what success looks like to an AI agent. The API returned a 200 OK status code. It delivered a perfectly formatted array of 50 strings, exactly as requested. To the code, this is a flawless victory.
Wow. So it has internal logic, but zero external common sense.
None.
Ah.
It lacked the spatial intuition to look at the array and say, hey, if I am searching for weather in Montreal, Montreal should probably be on this list.
So it just grabbed the top available item it had.
Yep. It quietly locked onto the nearest town that was on the truncated list, a town called La Prairie, 10 kilometers away.
So what does this all mean? Nobody did anything wrong.
That's the crazy part.
The builder followed the geographic rules, the checker validated the mathematical logic, the sentence writer perfected the grammar. They perfectly checked each other's homework.
And that is the heartbreaking, humbling truth of this entire deep dive.
Yeah.
Automated frameworks, design blueprints, adversarial checkers, they are all just representations. These autonomous agents were inside a sealed room. They all agreed with each other perfectly. The blueprint matched the code matched the tests, and the tests matched the text, which means they were all confidently, perfectly wrong together.
Because none of them actually possessed the human intuition to look out a real window.
Exactly.
They just looked at the data structures on the desk. Returning an array of strings was a success, even if it was completely divorced from reality.
But we have to make sure we land on the right takeaway here. The minions are not the punchline of this story.
Yeah, right. We shouldn't mock them.
No, they were amazing. They functioned at a level of diligence and integrity that human developer teams struggle to maintain on their best days.
Oh, absolutely.
The sealed room is the punchline.
The sealed room.
Right. The loop can perfectly verify coherence. It can check that every single piece of the system logically agrees with every other piece of the system.
Yeah.
But it cannot verify contact.
Contact with physical reality.
Yes. Something in every single loop has to open a window and look outside. A system can be logically consistent, pass 169 tests, possess flawless grammar, and still be entirely disconnected from the real world.
Which brings me right back to that empty office building we talked about at the very beginning.
Yeah.
I mean, as these autonomous tools get smarter, it is going to become so tempting to just let the machines run in the dark.
Oh, for sure.
To just trust the glowing green dashboards when we clock in. It feels incredibly safe when all the little check marks align and the agents tell us they fixed everything. But it leaves you with a really provocative thought to chew on.
Which is?
Think about your own workplace or your own projects or even just the systems you rely on daily.
Hmm.
Where are you perfectly validating your work inside a sealed room? Where are you relying on metrics, automated tests, and blueprints that all agree with each other, just, patting yourself on the back for a perfect score without ever actually opening a window to make contact with reality?
It's such a good question. Coherence is incredibly comforting, but contact is what keeps us safe.
It really is. Well, thank you for joining us on this deep dive into the server logs. Think about that sealed room today. Open a window. And until next time, we will catch you later.